In 4.6 Learning Objective A, we're going to go back to the unit circle, and now I'm going to show you if we go to the Algebra 2 graph paper where we put the degrees or the radians on the x-axis, and we're going to peel off the tangents around the unit circle and graph the tangents here. And this is the graph we're going to ultimately see if we were to use a graphing calculator. So here's how this one works. Remember by definition that tangent of theta is the same as sine of theta over the cosine. And remember here that the x is our cosine, the y is the sine. So all we do is we go and find the tangent or the slope at each angle. So if you go to 0 degrees, which is right here, the tangent or the slope of that line is 0. So at 0 degrees I plot 0. If we go to 45 degrees, or pi over 4, definition is sine over cosine, so that would be the square root of 2 over 2, divided by the square root of 2 over 2, which equals 1. So at pi over 4, the tangent is 1. Now, if you go to pi over 2, or 90 degrees, the slope of the vertical line, by the way, is undefined. So you have to be able to identify on Algebra 2 graph paper that the slope is undefined. What that ends up becoming is something that we did back in Algebra 2, which is an asymptote. So what you're going to see is an asymptote is actually going to drop right here at pi over 2 because the slope's undefined. Now, what happens in between 0 and pi over 2? What happens to the slopes? Well, look at the line. If we go down lower than pi over 4, somewhere in here, if you look at the slopes, at pi over 6, the slope is smaller, and then it gets smaller as we get closer to 0. As we go from 45 degrees to 90 degrees, the slopes get steeper or larger. So what happens is this graph, the slopes actually get close and approach this asymptote. Now we know at pi over 2, again, there is no defined slope. Now as we work our way toward here, notice the slope becomes negative. This is a very steep slope. Then we get to a less steep slope, but it's still negative. Then the slope zeroes out at 180 degrees, or 1 pi. So at 1 pi, the slope is 0 again. And what happens down here, the slopes were negative, so it looks like this. Then we're going to continue on into Quadrant 3. Here the slope is positive, and it's a smaller slope. Then it's positive and more steep, positive and even more steep. So what's going to happen is as we move up here, it's going to start to grow. Be careful, at 3 pi over 2, or 270, we actually hit another asymptote. So we're going to have to drop an asymptote here, and we're going to move that asymptote to be right here at 3 pi over 2. So we're going to see the graph go like that. And it basically just starts all over here. It's going to be negative again. Now this is what one cycle of tangent looks like. I personally like to come over here and finish off this side. Here if I go from 0 to negative pi over 2, which would be this direction, if you look at the slopes, they're all downhill and negative. So what happens is we have that asymptote pop up again. It's going to happen right about here. So let's drop that once more. So there's the asymptote at negative pi over 2, and it goes like that. What the tangent function looks like is almost like a cubic function. It's this pattern here that repeats itself over and over. Keep in mind the slopes on here happen of 0 at 0 degrees and 180. So here's 0 degrees, here's 180 or 1 pi, here's 2 pi. So you're going to see the slopes be 0 and have x-intercepts at those corresponding values. This is how you graph the tangent function.